All right, so today we want to focus on another standard. It's called Standard 8NS2. And the piece we're going to learn is how to approximate an irrational number. All right, so when I say approximate an irrational number is something like, like 3 pi. Pi is irrational, or the square root of 15, because there's no number times itself that's going to give you 15. So the square root of 15 is irrational. So we're going to learn how to approximate things like this. You may even see something that looks like this at some point. Okay, that's 2 times the square root of 3. But we're going to talk about pi last, and we're going to just work on the square roots of imperfect squares today. And it's just an introduction. So to introduce standard 8NS2, I'm going to talk a little bit about area, because when we do real life problems, I'm going to tie it to area. And I want you to know about it even before I get to those kinds of problems. So if you don't know what area is, I'm going to show you a little video. It's elementary. Sorry, guys. But it explains area really well. So let's take a look at that.
This sentence is grammatically correct.
Maybe we should paint this wall. Well, first, we should figure out the area of the wall. What is area? Area is the measurement of the space inside of a shape. You can calculate the area to figure out how big a room is, or how much carpet you need to cover a floor. You can calculate area to find out how much wallpaper you need, or how much tile you need to cover a wall. In our case, we can calculate the area of the wall to figure out how much paint we need. What are square units? You can find the area of a shape by dividing it into equal squares and counting them. These squares are called square units. This shape is 3 squares wide and 3 squares tall. There are 9 square units inside the shape. So the area of this shape is equal to 9 square units. Great, Moby. We can describe an area in square units. This rectangle is 10 squares wide and 5 squares tall. It has an area of 50 square units. What is the area of this shape? It's a little tricky because there are 2 half squares here. First, count the whole squares. There are 10 square units. There are also 2 half square units. 2 half square units make 1 whole square unit. So this shape has an area of 11 square units. How do you calculate area? What is the area of our class garden? I know that our garden is 6 feet long and 4 feet wide. We could divide the garden into 1-foot squares. There are 24 of these 1-foot squares, so our garden's area is 24 square feet. Instead of counting all the squares, you can multiply the length and width to find the area. 6 feet times 4 feet is equal to 24 square feet. Let's see. This wall is 4 meters by 2 meters. Multiply to find the area. 4 meters times 2 meters is equal to 8 square meters. Since we know the area of our wall, we can figure out how much paint we need. think we've got enough paint, Moby.
All right, guys. And so you're going to see why I started off with area by the end of the lesson, but let's just talk about what area is. It says the amount of space that will fit. So what is area? The amount of space that will fit, and you need to fill this in with inside a shape or figure. Area is measured in square units. And the reason why it's measured in square units is because area is the actual amount of squares that will fit inside of a figure. They're actually squares, guys. So, like, even if you look at the floor right now, you'll see on my floor in this classroom, you see a whole bunch of squares. Or if you go in the house, like maybe in the kitchen, you'll see a whole bunch of squares in there, for the kitchen tile in a lot of people's kitchens. With the backsplashes, you'll see little squares. The shower backsplash, you see a lot of squares. That's because you need areas in those square units, and you need area to find out how many tiles you need for to either put as a black backsplash, or to put carpet down, or to figure out how much paint you need to buy. Okay. But again, area is and always going to be in square units, where it's feet square or square feet, or meter square or square meters. Could be inches square. Okay. All this is how you measure area in square units. All right, says let's calculate the area of a few squares. So you see you have a blue square, an orange one, yellow, and then a larger yellow one. So it says, what is the area of the orange square? Well, you can count the individual squares if you want to, but that's not necessary. Okay, it's 9 individual squares there, so we know it's 9 square feet. Excuse me, not feet, but 9 square units. But you could say this is 3 units long, or 3 units long, and this is 3 units wide, and just say 3 times 3 is 9. So it's 9 square units. I'm going to just put unit square. And we got that from 3 times 3. Side times side, okay? And I can say side times side because it's a square, and the sides of a square are the same. All right, what is the area of the blue square? I'm going to look at this side as 1, 2, 3, 4, 5 units long, and then 1, 2, 3, 4, 5 units wide. So 5 by 5 is 25 square units. So side times side is 25. Okay, and you just do side times side. And then it says, what is the area of a yellow square? I'm making a video. The area of the yellow square, I'll come to you when I finish. The area of the yellow square, you got 1, 2, 3, 4, 5, 6. This is a 6 by 1, 2, 3, 4, 5, 6. And you really shouldn't even have to count that other side because it's a square. So if one side is 6, the other side is 6. 6 by 6, so instead of you counting up all these individual squares, you should know that they're going to be 36 square units in it, okay? So D says, instead of counting the squares inside the figure, what could you do with the side lengths? You could, number 1, multiply the side lengths as we did. So basically you're looking at side times side, okay? Just like we got 3 times 3, 5 times 5, 6 times 6. That's side times side. But there is a second way. I don't know if you all have seen this. Instead of 3 times 3, you can do 3 squared. You read this as 3 squared. So basically you square the number. And to square a number, there's a little button on the calculator. Let me see if I can find it on this calculator that we have here. So I can show you all. All right, y'all see that button I keep hitting? That's the square button. I'm going to get rid of that. Let me clear this out. Okay, that's the square button. So you could just take 3 and square it. Hit that button. Or you could take 5 and square it. It gives you 25. Or you could take the 6 and square it. So that X with the little 2 just means you can square your number. To square your number, the calculator just multiplies it by itself, okay? All right, so we know we can also square. I'm going to flip this back over. So the second way would be to square the side length. And in terms of symbols, we could just put S squared, okay? S is going to stand for the side length. Or you could just put side squared for me, okay? So I'm going to show you. Those are the two ways. You can multiply the side lengths, do side times side, or just do side squared. I'm going to give you a calculator so you could just use the little X squared button to square it, okay? Here, instead of 5 times 5, we could have gone with 5 squared, which is also 25. Instead of 6 times 6, we could have gone with 6 squared, which is still just 36. I want you to get used to doing it, squaring it, okay? All right, let's go on to E. E says, now suppose I gave you a square and its area. So now instead of giving you the side lengths, I'm just going to tell you that the area of a square is 100 square units. Okay, I'll tell you that. Could you use the area? When I say use this, could you use the area to determine the side length of the square? And if so, how? So I'm going to go back up here and look. Here my area was 9 square units. Not 9, but 25, sorry. Here my area is 25 square units. Is there any way I can use this 25 to figure out that the side lengths were 5? Okay, so what do I do with 25 to get a 5? Here, the area was 9 square units. So what are you doing with a 9 to get a side length of 3? Here, the area was 36 square units. So what could we do with a 36 to get a side length of 6? Remember, that's my side length. And this was my area. So if I wanted to work backwards, could I? Here's my area. Here's my side length. Here's my area of 36. And that was my side length. So it's got to be one operation you're using to start out with an area and end up with a side length. Start off with an area, end up with a side length. Start off with an area, end up with a side length. And I don't know if you all are familiar with this or not. Yes, you are, because we did it in standard 8N as 1. Okay, my area is 25. So if I take the square root of my area, I end up, square root of 25 is 5. Okay, that gives me the side length. Well, the area of the orange square was 9. Look what happens when I take the square root of 9. I get 3, and 3 was my side length. All right, look what happens when I look at the yellow square. If I take the square root of 36, I get 6. I get the side length. So if I tell you that this square right here, and I know you don't have it on your paper, has an area of 100 square units, all you need to do is take the square root of the area. Well, what is the area? The area is 100. And it's going to give you the side length, which is 10 units. And side length is never in square units. Only areas in square units. So just put units, not unit square. And I can check 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So basically, guys, if I gave you the area of a square, all you have to do to determine side length is and it's going to be yes. Let's take the square root of the area. That's all you're going to do. Okay, this is very, very important, guys. If you take the square of the area, you end up with the side length of the square. And pause the video if I'm going too fast. If you take the square root of the area, then all you have to do is, it gives you the side length of the square, okay? So let's look at some examples. Working backwards, it says, find the side length of a square if the area is 36. So I'm going to take the square root of the area to get my side length, guys. Therefore, I'm going to take the square root of 36. The square root of 36 is 6. 6 is my input units. 6 is my side length. And you can think about it. 6 times 6 is what gives us the area of 36. Find the side length of a square if the area is 144 square units. Or you could think what times itself gives you 144. That would have been, the side lengths would have to be 12 and 12. So it'd be 12 units, not unit square, okay? So the side length is 12 units. Okay, I want you to take a look at something. The square root of 36 and the square root of 144. And they end up being a rational number because they're perfect squares. When you take the square root of a perfect square, you get a rational number. Now watch H. Find the side length of a square when the area is 51 square units. So the area is 51 square units. So I take the square root of the area. It's supposed to give me the side length. But what do we know about 51 though? As opposed to 36 and 144. 36 and 144 are perfect squares because 6 times 6 is 36 and 12 times 12 is 144. But what times itself gives me 51? What whole number times itself? Well, there is no whole number times itself that's going to give you 51. So the square root of 51 will end up being some irrational number. If it's irrational, it's just going to keep on going and going and going. It's not going to repeat. So what do you do to find those side lengths? Well, on these, we're going to have to approximate it or round it off, okay? Because we end up with some irrational number instead of some rational number. So that's the whole standard. So standard 8NS2, we're going to use rational approximations of irrational numbers. Now today we're just going to locate them on a number line, but tomorrow we might compare them, okay? So we've got to compare them. We got to locate them on a number line. We got to estimate their value. So today we're just going to estimate their value and locate them on a number line. So we're going to be doing, I'm going to underline it in green. We're going to locate them on a number line, and we're going to estimate their value. We want to compare today. All right, so let's take a look. I want to find the square root of 51. So if you'll look at what I have a number line here. And on this number line, it goes from 0 to 10. And in the middle, between 0 and 1 is 0.5 or 5/10. In between 1 and 2 is 1.5. In between 2 and 3 is 2.5. In between 3 and 4 is 3.5. So I got the halves label as well, okay? But if you look at the top here, I have all of these are perfect squares. Well, actually, they are square roots of perfect squares, okay? At the top. So the square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. The square root of 16 is 4. So 5 is the same as the square root of 25. 6 is the same as square root of 36. 7, same as square root of 49. 8 is the same as square root of 64. So you can see how I have it labeled. So if I want to approximate, because I'm going to have to approximate these, the square root of 51, still thinking about this. If I want to find that side length, try to figure out what number times itself gives me 51, I'm going to show you how to do that using a common sense approach. Okay? We got to approximate. We're not going to get an exact answer, guys. So I'm going to look up here. Well, I know the square root of 51 lies between these two square roots, because 51 is between the perfect square of 49 and the perfect square of 64. So the square root of 51 is somewhere in between these two, because 51 comes after 49 but before 64. That tells me that the square root of 51 is in between 7 and 8. It has to be, because square root of 49 is 7 and the square root of 64 is 8. So the square root of 51 has to be between 7 and 8, because it's in between the square root of 49, square root of 64. So it says, using a number line, determine the two integers that the square root of 51 lies between, okay? So the square root of 51 lies between these two perfect squares, though, which tells me the square root of 49 is 7. That's the whole number 7. Square root of 64 is 8. So I know the square root of 51 is 7 point something, because it's in between 7 and 8. So the two whole numbers are 7 and 8. Okay? Square root of 51 lies between 7 and 8, because it's 7 point something. All right, it says, could you approximate the square root of 51 to the nearest tenth? I'm going to show you how, okay? So I know the two whole numbers it lies between would be 7 and 8. So I'm going to think about, if I have place value system, tenths is one place after the decimal. So to the nearest tenth, I just need one place after the decimal. Well, 7 is the same as 7.0. Now this is in terms of tenths instead of a whole number. So you just change 7 to tenths, which is 7.0. And I'm going to change 8 to terms of tenths, which will be 8.0. And I can think about all the tenths in between 7 and 8. 7.1, 7 and 2 tenths, 7 and 3 tenths, 7 and 4 tenths, 7 and 5 tenths, 7 and 6 tenths, 7 and 7 tenths, 7 and 8 tenths, 7 and 9 tenths, and then 8 and 0 tenths, okay? So to the nearest tenth, all I have to do is figure out which one of these could I square to get close to 51, okay? Because I'm trying to approximate the square root of 51 to the nearest tenth. So I already know 7 times 7 is 49, okay? So I know that's not going to be as close as possible to 51. So let's try 7.1 squared. So you're going to take your calculator, you're going to pause the video, and you're going to do 7.1 squared. I'm going to do it here. 7.1 squared is 50.41. Okay, that's okay. I'm going to have to do this, guys. Okay, so this ends up being 50.41. That's close to 51, but what if I square at this 10? 7.2 times 7.2, or 7.2 squared. Let's see what I get. Okay. 7.2 squared. 51.84. Okay. So over here, I end up with something over. It's 51.84. But if you think about which one of these 51 is closest to, is 51 closest to 51.84 or 50.41? Well, 50.41 compared to 51, we would need to add, let's see, that's like $50.41. You're 59 cents away from being at 51. Okay? Here you're 84 cents over from 51. So it's closer to be 59 cents away from 51 than 84 cents over. This is 84 cents, that's 59 cents. So I'm going to say that to the nearest tenth, the square root of 51 is 7.1. Okay? To the nearest tenth. So Now, if you want to get to the nearest hundredth, it says, could you approximate the square root of 51 to the nearest hundred? So now all you have to do is take your tenths. Well, 51 is in between. Let me erase this. 51 was in between. It's in here. 51 is fall somewhere in here. It's in between 50.41 and 51.84. So that means the square root of 51 is in between 7.1, although it's closest to 7.1. It's in between 7.1 and 7.2. So I'm going to use, just like I used the whole number to help me with the tenths, I'm going to use the tenths to help me with the hundreds. So the tenths, I know that the square root of 51 is in between 7.1 and 7.2. Well, hundreds is not one place after the decimal, but 2. So here I have one number after the decimal. So when I get down here, I'm just going to add a 0. So now I have 2. So 7.1 is the same as 7.10. And 7.2 is the same as 7.20, but they're in terms of hundreds because there are 2 places after the decimal now. 1, 2, 1, 2. So just like I took the whole number and added a 0 to get the tenths, I'm going to take the tenths and add a 0 to get to hundreds. Now think about all the hundreds in between 7.10 and 7.20. 7.11, 7 and 12 hundreds, 7 and 13 hundreds, 7 and 14 hundreds, 7 and 15 hundreds, 7 and 16 hundreds, 7 and 17 hundreds, 7 and 18 hundreds. Okay, I'm going to need a little more room. 7 and 19 hundreds, 7 and 20 hundreds, which is the same as 7.2. Okay? All right, so I already know 7.1 times 7.1 ended up being 50.41, but I'm trying to get as close as possible to 51. So what's 7.11 times 7.11? Or just take your calculator and do 7.11 squared. And pause the video at any time if you want to practice on your own. 7.11, and then we're going to square it. 50.55 to the nearest hundred. That 2 tells that 5 to stay the same. We're going to round it to the nearest hundred. So it's 50.55. Well, it's close to 51. See if we can get close to 7.12 squared. Okay. So let's do 7.12 squared. 7.12, and then we're going to square it. That 4 tells that 9 in the hundreds place to stay the same. So this is going to round off to 50.69. And you gotta remember, when you're rounding to the nearest hundred, the number in the thousands place tells the number in the hundreds place what to do. So if the number in the thousands place is 5 or more, the number in the hundreds place goes up. If the number in the thousands place is not 5 or more, the number in the hundreds place stays the same. Let's see if we can get close to the 51 with 7.13 times 7.13. 7.13. 7.13 squared is 50. So this 6 is in the thousands place. Well, it's going to tell the 3, which is in the hundreds place, to go up because 6 is 5 or more. So that's going to go up to 50.84. That's closer to 51. Let's try 7.14 squared. Okay, 7.14. 50, that 9 tells that 7 to go to 8, so that's 50.98 to the nearest hundred. I can already tell you it's going to be 7.14, guys. Because when I try this, if I square 7.15, you're going to end up with 51.12. Okay. Well, this is like, I'm treating it like money. That's 12 cents from $51. And this is just 2 cents from 51. So if you think about it like money, you're good to go. 2 cents is closer. 2 cents from 51 is closer than 12 cents from 51. So I already know to the nearest hundred, the square root of 51 is going to be approximated to 7.14. So it says, sis, go back and write down the side length. Let me erase this. Go back and write down the side length of a square with an area of 51 square units on H. So I'm going to go back to H. I'm almost done. I'm going to go back to H. So it says, find the side length of a square with an area of 51. So this, I told you have to approximate it. So this side length is approximately 7.14 units. You got to approximate it. You could approximate it to the 10th and stop, but I like approximating to the nearest 100. Approximate them to the nearest 100. All right. You're going to try the square root of 8, approximate it to the nearest 100. So this page is what I want you to do for homework, okay? And you can check it with a peer if you're working in class. So this is going to be homework. Approximate I spelled that wrong. Approximate the square root of 8. And you're just going to follow the steps on this page, okay? And that's all I want you to do. And tomorrow we'll look at the square root of 8 and we'll look at this as a bell work. This is going to be your do now in your video tomorrow, okay? And I'm also going to go over your homework tomorrow. All right, guys, that's it. Thank you.